Hello everyone. Today we want to learn about the design of experiment, statistical design of experiment. And we want to know that, for example, how many approaches do we have when we are saying that, okay, design of experiment. What does it mean, in fact, when we say that we are working we want to design an experiment. So let's go to the course note. Okay. Like always, like before, the course notes, the lectures, they are copyrighted material from Professor Alex Davis. Make sure that if you want to share the notes with someone else, you would get the permission from him. We're in chapter 3. So basically, chapter 3 is very short. It's like that. There's no mathematical equation or something like that in it. We just want to know the concept and the meaning of the statistical design of experiment. You will see that it's like that. I'm going to ask you to read some materials by yourself, but I will explain to you that like the different approach that we have. The main maths behind it, like the stats analysis, is going to come to the picture in chapter 4, which we are going to cover as well for this week. So is that we are going to talk about the like single experiments and designs this week as well. Okay, here are our learning objectives. We want to learn about the objective of experimental design and the role it plays in the knowledge discovery process. I learn about different strategies of experimentation. So we have 3 main strategies of experimentation, which I'm going to go through an example with it about it. And then we want to understand the nature of the experimentation. Okay, I'm going to talk about the design of experiments, like when we want to learn about the concept of it. I will talk about an example on golf, playing golf. And I got the example from our reference book, Montgomery book, Design of Experiment. I think that's a good, very simple example, but at the same time, when we want to develop learning about the, like, let's say, single factor experiments, like most factorial experiment, factorial design, all of them, we can use this example later in the course as well. So let's say for playing golf, I would say that I really like to play golf, but not enjoying practicing, which is very true about myself. So I'm looking for a simple solution to lower my score. So let's say what I'm going to do is that, let me pause the sharing. And let me just see. Okay, so it's like this. I would say that I have to consider, I don't want to do any practicing, like that much practicing, but I want to lower my score. I would say, okay, so let's see that how many factors it's gonna affect like my golf score. So in fact, we need to look at the factors that's gonna influence my golf score. I wrote them on the board just to save time while we are learning this together. I would say, okay, so I wrote down, like, you can come up with more than, like, more factors. These are just the simple ones that I could, I thought that they're good to mention, but you can come up with something else as well. So for example, the type of the driver that I'm going to use, or the type of the ball used for the practicing, like for playing golf, or walking or carrying the golf club, or riding in golf cart. The 4th one is the drinking water or drinking something else, like energy drinks or something like that, or anything while playing. Playing in the morning or afternoon, or playing when it is cool or hot. Type of the shoe spike, like worn like metal or the soft one. playing on a windy day or a calm day. So all of these things that I said, these are the factors that can affect, let's say, can affect, influence my score. So in design of experiment, when we say the first step that we need to do is that we need to identify the factors that's going to influence our result, the result that we are looking for. We can look at, like, let's say we have a distillation column and our hope is that we would get a, like, let's say methanol with some purity. Maybe that's your goal. The purity is your goal, is our goal. So this is just the golf example, right? So all of these ones are factors. When we are talking about the design of experiment, it's very important that we would know that, okay, so what are the factors that you're dealing with? Because the next step, we are going to make like some hypothesis and say that, okay, so let's say that which factors are more important. But before going to that, we need to learn about the strategies of experimentation. So let's say we have these 8 factors. I'm going to write down something here as strategies of experimentation. So generally, we have 3 strategies that we use when we want to talk about the experimentation. In fact, it's the general approach to planning and like conducting the experiment. And the first strategy, we call it best guess approach. So I'm going to write down here. So when we are talking about the best guess approach, is like that we are going. It's like selecting arbitrary combination. Then we would test them. Like when I say selection, is like they're selecting these factors, right? Arbitrary combination of this one, and then we would test it, like test our experiment and see that what's going to happen. So it's like that. It's like you're hoping to have the best guess, in fact. Okay, so that's the first one. The second one is that we call it one factor at a time. So with the one factor at a time, one factor at a time. So one factor at a time, you might see that as they would write it OFAT. So I'm going to write down here OFAT. And what happens when we are working with the one factor at a time, we can make a guess. It's like that, okay, so we are going to select one of the, like, we would select a starting point, like one of these factors. We are going to select one of them as a starting point, and then we would say we are going to set a level for it. And here, let me tell you something. When we say level, it means that, for example, drinking water or drinking something else. So here, my factor has 2 levels. You want to set the temperature to, like, let's say in distillation column, to 50 degrees centigrade or 60 degrees centigrade. So that's your level. So you would have 2 levels. So we are going to select this one of these factors as our starting point and would consider level for it. So we would say that at each time we are going to change one of these factors, like on the levels, and then we'll go to the next one. So we call this one factor at a time. The third one, which is the most practical one, is we call it factorial experiment. So I'm going to write down here, third one, factorial experiment. Okay. And then it has two categories, but I'm going to go to that quickly. So when we say factorial experiment, it's like that you're gonna choose a few factors, right? And then they're gonna you would vary them at the same time. So we would say factors are varied at the same time, like simultaneously, or together. So that one would be, for example, I would say in this experiment that I want to conduct, I would say, okay, so let's say choose factor number 4 and then factor number 6. It's like that drinking water or drinking something else as my like one factor. And then the second factor would be playing when it's cool or hot, for example. So I will change these two factors at the same time, like together. If like, let's say, I would say, okay, let's match water, drinking water, at the same time when I'm playing, like when it is hot. Or would say I was doing something else when it is hot again, or when it is cool. So this one is the factorial experiment. That's the one that we are working. We are going to work a lot in the while you are working on your like research on industrial applications. And then we would say these factorial experiments. It has two categories, as I said. One is the basic factorial design. It's the same as factorial design that probably you have heard many times. And then we have fractional factorial design. So I would have here two categories. Basic factorial design and fractional factorial design. So fractional factorial design, basic factorial design is that you consider all of the factors that you have, and then you would change them. Fractional factorial design is that like you would say, okay, so I'm gonna choose fraction of the factors, and I would like even the combination of them. And for each of these, we have a chapter in this course. So like that, the next chapter is that single factor experiment. And then, which we are going to talk about the like block. Next chapter, 4 is like that. We are going to talk about single factor. In chapter 5, we are going to talk about like blocking, like with the single factor experiments. We would learn about what is blocking. It helps, and it's very like common that we use the blocking. And then after that, we are going to talk about the multi-factor experiments, and then fractional factorial design or factorial experiments. So this is the general strategies that we use. As I said, when we go like further, we would learn more about these things. It's like that in each of these, but it's good that you know that. So when you hear that, when we say design of experiment, what do we mean by factors, and what do we mean by the levels? So it's like that. For example, I would say I'm looking for the 2 power k factorial design. It means that, okay, so I have k number of the factors, and each factor has like 2 levels. So we're going to talk about it, but just quickly, if you want to do as a practice right now, it's like that. Look at here, type of driver used, oversized or regular size. So this is going to be like you have 2 levels for this factor. So 2 levels for this one. This one, type of ball used, balata or 3 pieces. So this is, again, it has 2 levels. So when you have 2 options for that factor, when you consider, you can have 3 levels as well. But we start with the 2 levels in this course to learn it, to see how to deal with them. Walking or carrying the golf club, or riding in golf club, drinking water or something else. So it's like that. We would see these are levels, like the options that we have for the factors. And then we're going to learn how to show them for each of them, like how would we present them when we are working with them. And as I said, so this is just a general, like to have just a general idea. Okay, so let's go back to the note. So here was that we talked about, and I took these pictures from the U Waterloo's sports club. Okay. There are 3 keywords that we need to we need to consider, we need to be careful while working with experimental design. One is the randomization, replication, and blocking. Randomization is that, okay, so when you do your, we talked about randomization a lot, in fact. So we said that we are working with the random variables, and we are gonna consider, like when we want to get the experiment, run the experiments, we're gonna consider the random, like randomization in it. So we are, it's very familiar when you hear it. Replication, it's very important that we know the meaning of the replication. Replication means that you would do the experiment, and we're going to talk about that later as well in the next chapter. You would do the experiments from 0 to 10, like from scratch. So that's a replication. It's different than repetition. Repetition is that, like, for example, you have your experiment, it's running, so you're gonna, like, for a specific part of it, so you're gonna repeat it. But replication is that you would need to do the whole experiments in the replications. Blocking, we had an example for the blocking in chapter 2, but we have one chapter, like chapter 5, we are gonna talk about the blocking, like the whole chapter is about the blocking. It's mainly because when we wanna, when we have like lurking variables, so we would do the blocking, but as I said, we would talk about the blocking later. Okay, why experimental design? These are different, many reasons, in fact. Here are just some of them. They want a quality, like for quality improvement, development of new product or process, troubleshooting of the existing process, optimizing the plant and process operation, learning about and understanding why a process behaves the way it does. So we are going to, and there are many other reasons as well, but these are just a few of them. So we have two approaches. We would say the first one is the informed approach, and the second one is the directed one. The informed but passive observation is like that someone who knows about the process watches change and tries to deduce the cause. But the directed experimentation is that someone who knows the process causes it to change in a systematic fashion and watch the result of this of those changes. And here is the general like flow chart of it. So we say iterative, sequential nature of the experimentation. So look at this one: hypothesize, design, and analysis. In hypothesize, most of the time, because we make we have the hypothesis, we would form the whole experiment that we would have. Like we would say, okay, what's the objective we are looking for? All of those ones are in the hypothesis. And then we would do our design, do our analysis. Then we would say, okay, if the objective met or not. If the answer is no, we would go back to the design or hypothesis. If the answer is yes, this is a very, in my opinion, interesting part that we most of the time forget about it while we are working like outside the course, let's say. And it's like that, okay, so when you have the objective, this process takes time, right? So we need to think and look at it to see that if the objective changed or not. If the answer is yes, which is going to be unfortunate, but we need to go back to the hypothesis step. And if the answer is no, so we would tentatively accept the result that we would have. Okay, here is another important thing that we need to consider, and is that the experimental design is not a black box. So we need to keep in mind that, like, we are going to use chemistry, physics, engineering principles, as well as the statistics. So depending on the experiment that we are doing, we would need to consider all of those physics law and all of the laws that we would have. And another thing that we need to consider is that we talked about that like many times so far. It's like that we have the mechanistic models versus the empirical math models. And when we are talking about the design of experiments, we would need to consider all of them, right? So mechanistic is the one that we would have like physics law, for example, Ohm law. That's the gravity law. That's the mechanistic law. empirical math models are the like regression models and nonlinear regression models or linear regression models. All of those regression models, those are the empirical math models. Okay, so while I'm talking, you will see that I'm jumping from some of the slides. Already did that because this the main objective of this chapter is that we would know that what are the factors, what does it mean when we say experimental designs, what are the strategies that we need to use. But doing the calculation, everything is in the next chapter. I want to cover that one as well. Like all the time, we ask the students to go through these notes by themselves because we are going to repeat it a lot. It's just a bridging this chapter, and you see it's very like short chapter. It's like let's say it's just like an introduction, general introduction for the experimental design. So here is the experimental design procedure for avoiding the problems that occur in the analysis of the like happenstance data. Here is like, so we have the problem, and then the next column is the experimental design procedure for avoiding the problem. And like, for example, if we have inconsistent data, we would go with the blocking and randomization. If we have nonsense correlation due to lurking variables, we would say we'd go with the randomization. Like these are different kinds of the problem. But when we go to the like, when we are talking about the like, for example, more about the blocking in chapter 5, we are gonna go through the problems that it's gonna like in those situations we would go with the blocking. So we'll talk about it later. Okay, so that's all for this chapter. So the next chapter, I'm gonna talk, as I said, I'm gonna go through the single factor experiment, and I will talk about the when we wanna like we wanna change one, just one of these factors, what's gonna happen. I will do like we would use the t-test, ANOVA table, and all of those. So please look at the next chapter.